All right, so example 1, chapter 7. So chapter 7 is just a continuation of algebra. So we're going, chapter 6 was all about arithmetic and algebra and using signed numbers in our expressions. Now we're going to start doing algebraic expressions, some solving equations, things like that, substitution evaluation. So basically your chapter 6 and 7 put together is pretty close to algebra 1 as far as what you need to know out of algebra 1 for the purpose of this course. So the formula to calculate the number of joists J needed to cover a distance L in feet when spaced 16 inches on center is J equals 3/4 L plus 1. If the length is 44 feet, how many joists are necessary? So first thing I want to bring to your attention here is this is a pretty typical scenario for a word problem in this section. They're going to give you an equation. If they give you an equation, they're going to tell you what the letters represent. Okay. J is the number of joists and L is the distance in feet. So when you're reading your words on these problems, that's what you want to get out of your information. You want to know what the equation is, and whatever letters happen in the equation, whatever variables are happening, you need to know what those letters represent for the sake of what you're doing. Because then they're going to feed you more information and they're going to tell you one thing and ask you to find another thing. So if I read this carefully, it says the length is 44 feet. Which one is length, J or L? L is length, right? And it says length in feet, L in feet, this is 44 feet. They gave me the length in the right unit. They tend to do that, but if they gave the wrong unit, you might have to do some unit conversion. But I'd say more often than not, expect the units to be correct, all right? So they're telling me L equals 44, and they says how many joists, what are we looking for?
Joist.
Joist is what? What letter is joist?
J.
J. So they're telling us what L equals in the equation. They're asking us what J equals. So I'm going to take this equation, replace L with 44, and then try and find J. So J I don't know yet, equals 3/4 L. Now, one thing about algebra that you may or may not remember from algebra class in the past, when you have a number attached to a letter like this, that's a multiplication happening. They won't have a multiplication symbol typically on that expression. So 3/4 L means 3/4 times L. And since 3/4 is a fraction, I'm going to create L as a fraction. I'm going to put 44, which is the number L is. I'm going to put it over 1 so it looks like a fraction. Okay, fraction multiplication, in my opinion, is easier if everything looks like a fraction. So 3/4 times L, 3/4 times replacement for L. I'm substituting in what I know. And then the rest of the equation says plus 1, so plus 1. So they gave me an equation, they told me what L equals, they're asking me to find J. Everything on the right-hand side is what J equals, but it's not evaluated. Now it's just an order of operations problem. 3/4 times 44 is a product. Multiplication happens before the plus 1, which is addition. So, in fraction world, if I'm multiplying fractions, if a numerator object and a denominator object divide evenly or can be reduced, that's legal. So 44 divided by 4 is 11, and 4 divided by 4 is 1. Once everything on the bottom is 1, it no longer has to be even looked as a fraction. So I'm still looking for J. I haven't found it yet, so all right, J equals. Right here, 3 times 11 makes 33, and then plus 1. So the product happened to get 33. 33 plus 1 is 34. And J represents the number of what? Joists. So if J equals 34, that means we need 34 joists. You guys know what joists are? If you ever go into like a basement of a house that hasn't been finished, and you look at the ceiling, so I'll try and draw this. Here's the ceiling, right? And it hasn't been finished, so there's no like there's no drywall or anything on top of this on the ceiling. You're going to see all these. What you'll see from below will just look like 2x4s here. Every 16 inches is what they're supposed to be typically on a ceiling, I think. Anyway, that's what joists are. And if you look at a joist from the side, it's like a 2x4 with like a little piece of plywood, and then another 2x4. That's what it looks like from the side. And they're about yay big, and they come from the ceiling. It gives a gap between the top floor and the ceiling for you to put insulation if you want to do. That's what it's there for, plus it gives the floor support. So same thing happens in your top floor of your house, but typically the top floor has a finished ceiling always. Basements sometimes don't. So sometimes you can see the joists in the basement. You can't see them in other parts of the house. Again, equation, what the letters represent in the words, read the words so you know what the letters represent. They'll give you one thing, ask for the other thing. It's a pretty typical problem in this section.